Florida swamps reveal a shocking aftermath, and the new footage exposes what nobody expected to see in the Everglades. For over 20 years, this story seemed simple and hopeless. Burmese pythons arrived, native animals vanished, and the swamp fell almost completely silent. Now, cameras deep in the marshes are capturing something different, something that has biologists asking a question that would have sounded impossible just a few years ago. Is the Everglades actually starting to fight back? Deep inside the river of grass, the same Florida swamps you see in postcards and airboat tours are showing a dark twist beneath the surface. This is the place that filters drinking water for millions of people, softens the impact of hurricanes, and holds one of the richest webs of life in North America. For thousands of years, alligators ruled the channels, raccoons and opossums scurried along the banks, bobcats stalked the edges, marsh rabbits darted through sawgrass, and wading birds moved in numbers that seemed endless. That balance held for longer than any human memory. And then, one storm, one pet trend, and one predator changed everything in ways nobody fully understood until it was almost too late. What the new footage reveals is not some neat, happy ending where the bad guys lose and the good guys win. Instead, it shows an ecosystem still under extreme pressure, still flooded with invasive predators and even more invasive parasites. But woven through that chaos are signs of adaptation, recovery, and wild, messy resistance that nobody expected to see on this scale. The Everglades isn't just dying, it's fighting. And if you want to understand what this battle looks like, you have to start at the moment everything went wrong. In August 1992, Hurricane Andrew slammed into South Florida as a Category 5 monster, ripping apart homes, roads, and entire neighborhoods with winds that blasted past 165 miles per hour. Alongside the human disaster, something quieter and equally destructive happened. Exotic animal breeding and import facilities near Miami were shredded, cages broke, enclosures failed, and animals that had never belonged in these swamps spilled into the wild. Among them were Burmese pythons, snakes from Southeast Asia that had evolved in a very different world, but suddenly found themselves in the slow-moving wetlands of the Everglades. The hurricane was only half of the story. Through the 1980s and 1990s, Burmese pythons had already become a hit in the exotic pet trade, sold at reptile expos and shops to owners who thought a small snake in the palm of their hand was no big deal. They were cheap, easy to buy, and as hatchlings, they seemed gentle enough, nothing like the predators they would become. What most owners didn't grasp was that within just a few years, that cute snake could grow past 10 feet long and weigh well over 50 pounds, powerful enough to overpower mammals, birds, and even rivals in the water. When those snakes outgrew living rooms and plastic tubs, many owners made a choice they believed was kind, but in reality was catastrophic. They released them into the wild, often right along the edges of the Everglades. In their minds, they were giving their pets freedom. In reality, they were dumping a perfectly designed apex predator into an ecosystem that had no evolutionary defense against it. Burmese pythons are built for ambush hunting in exactly the kind of terrain the Everglades offers. Their patterned scales blend into dead grass and murky water so perfectly that you can be standing just a few feet away and never notice them until it's too late. Heat-sensing pits along their jaws allow them to detect warm-blooded prey even in total darkness, turning night into their hunting playground. They can stay submerged for long stretches without surfacing, slipping through canals and backwaters like silent shadows. A single female can lay up to 100 eggs at a time, and with no natural predator knocking those numbers down, the population exploded. Today, wildlife agencies estimate that there may be anywhere from 100,000 to several hundred thousand Burmese pythons spread across South Florida. That number is not a rough scare tactic. It's backed by years of fieldwork and studies that tried to put hard data on something that felt almost unreal to people on the ground. One of the most important pieces of that data came from biologists Michael Dorcas and John Wilson. Their long-term study compared mammal sightings along Everglades roadways before and after the python invasion took hold. In zones where pythons were most heavily established, raccoon sightings dropped by more than 99%. Opossum sightings fell by close to 98%. Bobcat numbers dropped sharply, and marsh rabbits and foxes became nearly impossible to find in some survey areas. This wasn't a slow, gentle decline. It was almost an erasure. Researchers who had spent decades driving Everglades roads at night described something chilling. They could travel for miles without seeing a single small mammal cross the pavement in places that had once been alive with movement and glowing eyes. The swamp that had breathed and pulsed with wildlife now felt empty, like a stage after the cast had vanished. Florida's response to this crisis grew more public and more desperate over time. The Florida Python Challenge, an annual hunting contest with cash prizes for people who remove the most pythons, grabbed national headlines and clips on news shows. But behind the flashy coverage, the numbers told a harsher truth. Even during a full contest period, total captures usually only reached the low hundreds, a tiny fraction of the estimated python population. It was like bailing out a sinking ship with a small bucket. Since 2017, the South Florida Water Management District has run a paid python removal program, hiring contracted hunters to work year-round across public lands. These hunters have collectively removed more than 20,000 pythons from the landscape. That sounds huge until you remember the scale. A population likely in the hundreds of thousands and still growing. The core problem isn't human effort. It's the python itself and the environment it lives in. Thermal imaging drones, once seen as one of the most promising tools, struggle in the Everglades because pythons are cold-blooded. When the air, water, and mud are almost the same temperature as the snake's body, heat-based cameras fail, turning those reptiles into ghosts. Mechanical lures and decoys don't help much either, because pythons are ambush predators that rely on perfect stillness and opportunity, not chasing moving targets. The most successful method so far has been something researchers call the Judas snake technique. In this approach, a captured python is fitted with a radio transmitter and then released back into the swamp during breeding season. That one snake becomes a guide, leading trackers to clusters of other pythons gathered nearby. It works, and it has led to significant removals in specific areas, but not at a volume large enough to cut down the overall population in a meaningful way. Then, just when scientists thought they understood the basic shape of the crisis, field data started showing something that made the situation more unsettling and more complicated. Dr. Ian Bartoshek and his team at the Conservancy of Southwest Florida, who have spent years following radio-tagged pythons through Big Cypress National Preserve, began noticing shifts in how these snakes behaved over multiple seasons. Areas that had once reliably produced python captures began going quiet. Not because the snakes had disappeared, but because they appeared to be moving away from human activity corridors. That pattern suggested at least two possible explanations. One is that individual pythons were literally learning to avoid detection, responding to human presence by changing their routes and habits. The other is even more unsettling. Natural selection may be at work, favoring the most cautious and elusive individuals. Bold snakes that cross roads or linger near people get captured and removed. The stealthiest ones survive and pass those traits on. In both cases, the conclusion is the same. A predator that was already incredibly hard to find is becoming even harder to track. And while public discussion stayed locked on python numbers, another threat was quietly spreading through the swamp, riding along with the invasion but following its own path. Dr. Cristina Romagosa, a research scientist at the University of Florida's Institute of Food and Agricultural Sciences, has spent years studying a parasite called Rhyleatina orientalis, better known as the snake lungworm. Like the python itself, this parasite is native to Southeast Asia and arrived in Florida through the same chain of events. Burmese pythons can carry the lungworm with little noticeable harm because their bodies evolved alongside it over thousands of years. Florida's native snake species, on the other hand, have no built-in resistance. The infection cycle is disturbingly simple. An infected python sheds waste filled with parasite eggs into the water. Cockroaches and other invertebrates feed on that waste, becoming carriers of the larval stage. Frogs eat those infected insects. Native snakes eat the frogs. Once inside a native snake, the larvae leave the digestive tract, burrow through tissue, and migrate into the lungs. There, they attach, feed, and multiply. Romagosa's work has documented native snakes suffering severe respiratory distress and losing weight, and in advanced cases, dying from suffocation as their lungs fill with parasites. At least 18 native snake species have tested positive for the lungworm, and confirmed cases have been found well north of the original python range, stretching toward the Jacksonville area. Most alarming of all, researchers have now confirmed that the lungworm is spreading between native snakes independently of pythons. Even if every python in Florida somehow vanished tomorrow, this parasite would remain established and self-sustaining in the ecosystem. Inside this grim pattern, one detail stands out as truly strange and potentially hopeful. The Florida cottonmouth, a venomous pit viper that lives throughout the same infected wetlands, has consistently tested clean. Across multiple surveys, even in heavily affected regions, cottonmouths show no signs of lungworm infection. Scientists don't yet know why. It could be related to immune response, blood chemistry, or some other biological factor that hasn't been identified. But the implication is huge. If researchers can figure out what makes cottonmouths resistant, that discovery might eventually help protect other native snake species from the same parasite. While that mystery continues to hang over the swamp, Florida wildlife officials made a decision that sounded almost backwards at first. In the middle of an invasive snake crisis, they began releasing more snakes into protected habitats. This time, though, it wasn't a foreign invader. It was a returning native, the eastern indigo snake, the longest native snake species in North America. Eastern indigos can grow past 8 feet long, wearing glossy blue-black bodies that make them stand out against pine forests and scrub when the light hits them. They have a reputation as one of the most effective natural predators of venomous snakes in their range. Unlike the python, an indigo doesn't rely on constricting its prey. It uses powerful jaws and speed to overpower smaller animals, and it is largely immune to the venom of native pit vipers, including rattlesnakes and cottonmouths. The eastern indigo didn't vanish because a new predator killed it off. It vanished because its habitat disappeared. These snakes depend heavily on the burrows of gopher tortoises for shelter and temperature control. As longleaf pine forests and scrublands across North Florida were cleared for development and agriculture, gopher tortoise populations collapsed. The indigos that relied on their burrows collapsed alongside them. By the late 1970s, eastern indigo snakes were considered functionally extinct across much of North Florida. For decades, conservation groups, including the Central Florida Zoo's reintroduction program working with the Apalachicola Bluffs and Ravines Preserve, pushed back against that loss. They built captive breeding programs, restored habitat, and carefully reintroduced both indigo snakes and gopher tortoises, trying to rebuild the original relationships that had once defined these landscapes. In late 2023, that long work finally delivered a milestone. Biologists had waited roughly 50 years to see. Trail cameras captured footage of wild-born eastern indigo hatchlings moving through restored habitat in North Florida. It was the first confirmed wild reproduction of the species in the region in about half a century. For the scientists and staff who had devoted years to this project, the footage was proof that a native apex predator wasn't just surviving on reintroduced individuals, it was reproducing on its own. At the same time further south, researchers tracking radio-tagged pythons in Big Cypress National Preserve documented something rare that had never been formally confirmed before. One tagged python was found dead, killed by a native bobcat about half its size. Trail cameras from that area also recorded other predator behavior: alligators preying on smaller pythons, and native predators attacking pythons during vulnerable moments, especially after large meals when the snakes are slower and less able to defend themselves. This doesn't mean native wildlife is suddenly winning the war. Pythons still vastly outnumber the predators capable of challenging them. But it does prove that the relationship between the invasive predator and native species is no longer completely one-sided. The Everglades is not just a victim, it is pushing back, even if only in pockets and moments. All of these threads, python expansion, predator adaptation, parasite spread, and native snake recovery, are now moving toward an outcome nobody can predict with confidence. Python populations are still pushing north along waterways and warming habitat corridors. Eastern indigo populations are slowly expanding outward from restored habitat in the north, growing step by step instead of in sudden surges. Their ranges are creeping toward each other, and at some point, those ranges are likely to overlap. At the same time, the lungworm parasite is also moving north, raising a tough question. Will eastern indigos encounter this parasite before researchers understand whether they have any natural resistance, or could they face the same respiratory damage that is already sickening other native snakes? So what does the new footage from Florida's swamps really show? It doesn't show victory. It doesn't show complete collapse. Instead, it captures a living system under enormous strain, with hundreds of thousands of invasive pythons still on the move, and a self-sustaining parasite digging deeper into the native snake community. Yet, woven into that pressure, it also shows something the Everglades hasn't clearly shown in more than 20 years: signs that native wildlife is adapting and, in some cases, fighting back. We see bobcats preying on pythons and winning at least some of those encounters. We see alligators turning smaller pythons into meals when the opportunity appears. We see eastern indigo snakes hatching in the wild for the first time in half a century, reclaiming their role as native top predators one step at a time. And we see scientists chasing answers hidden inside the cottonmouth's strange resistance to a parasite that has already devastated other species. No one who studies this crisis is calling it solved. The python population is still enormous. The lungworm parasite is still spreading. The Everglades still faces heavy human pressure from development, climate change, and pollution. But for the first time in a very long time, the story no longer looks like a simple straight line where one invasive predator wipes out everything in its path and nothing fights back. Instead, the new footage from Florida's swamps reveals something harder to define, but far more powerful. It shows an ecosystem that is wounded, but still trying to heal. It shows predators becoming prey, native species returning to old ground, and hidden biological defenses that may hold the key to protecting entire families of animals. Most of all, it shows that even in one of the worst invasive species crises in American history, the outcome is not fixed. The Everglades is still in danger, but it isn't done. Somewhere between the quiet, empty roads and the trail cameras catching bobcats dragging pythons through the grass, a new story is forming. The question now isn't whether the swamp survives exactly as it once was. That time has already passed. The real question is what kind of Everglades comes next, and how much of this unexpected fight back we're willing to protect, support, and learn from before the balance tips again. What do you think happens next in the Everglades as native predators rise, invasive pythons push north, and a hidden parasite rewrites the rules of survival in Florida's swamps? You can see it in the way scientists are shifting their questions. For years, the only real focus was, how do we get rid of the pythons? Now, the questions are splitting and multiplying. How do we protect native snakes from a lungworm that no longer needs pythons to spread? How do we make sure eastern indigo snakes reclaim more of their historic range without walking straight into a parasite they may or may not be able to survive? How do we restore enough habitat that the Everglades and the forests to the north can support real predator diversity again, instead of a handful of species trying to hold everything together alone? Some of the most important work isn't happening in the swamp at all. It's happening in labs and conservation centers, where biologists are digging through cottonmouth blood samples, tissue, and immune markers, looking for the hidden clue that explains why this one native snake seems to shrug off a parasite that is wrecking others. If that resistance turns out to be something that can be understood, and maybe even shared, through breeding choices or future medical treatments, it could change the outlook for dozens of species at once. At the same time, captive breeding programs for eastern indigos and gopher tortoises are slowly turning years of patience into networks of living animals that can step back into the wild, one release at a time. And then there's the human side of all this. Hunters and contracted python removal crews are learning the swamp in a way that goes beyond a single contest or paycheck. They are building mental maps of where pythons hide, where native wildlife still hangs on, and where the balance feels close to tipping. Many of them have watched the footage you saw in this video. Bobcats dragging pythons, alligators striking at just the right moment, indigo hatchlings slipping out of burrows. And they're starting to see their work, not just as a fight against one species, but as part of a larger attempt to give the Everglades room to adapt on its own terms. None of this guarantees a happy ending. The python population is still massive. The lungworm is still marching north. Climate change is warming water and air, opening new corridors that make it easier for invasive species to spread and harder for stressed ecosystems to keep up. But if you step back and look at the story not as a single disaster and not as a single miracle rescue, you see something more complicated and more real. You see a living system trying to rebalance itself with the tools it still has: predators, prey, hidden immunity, and a few determined humans willing to spend years chasing snakes through sawgrass and knee-deep water. So when you watch that new footage from Florida's swamps, the bobcat standing over a python twice its length, the indigo snake sliding through a forest that almost lost it forever, the cottonmouth coiled in water that should be crawling with parasites, but somehow isn't, you're not just seeing shocking moments, you're seeing snapshots from a long, unfinished experiment. What happens when an ecosystem pushed past its limits starts to push back? The Everglades may never look exactly like it did 50 or 100 years ago. But if these signs mean anything, they mean this: the fight is not over, and the outcome is not written yet. When you think about the future of Florida's swamps, do you see a landscape that slowly drowns under invasive species and hidden parasites? Or one that claws its way into a new kind of balance where native predators, resistant species, and careful human help keep the worst damage in check? Wildlife officials watching all of this unfold know that whatever comes next will not be simple. They're dealing with an invasive predator that can lay dozens upon dozens of eggs at a time, a parasite that has already broken free of its original host, and a changing climate that keeps tilting the odds. But they're also working with something powerful that doesn't show up in charts or reports: time. Every year that eastern indigos hatch in the wild, every season that bobcats and alligators learn a little more about how to turn pythons into prey, every new clue hidden in a cottonmouth's resistant lungs, adds one more piece to a puzzle the Everglades is trying to solve from the inside out. Maybe that's the real shocking aftermath the new footage reveals. Not just that the crisis is worse and more complicated than anyone thought, but that the swamp itself is still searching for ways to survive it. The cameras in Florida's wetlands are no longer just documenting loss. They're catching the first hints of a counterattack. And if the Everglades can keep pushing back against the weight of invasive species, parasites, and human mistakes, the question each new clip raises isn't just, what went wrong anymore? It's, how far can this ecosystem go in fighting to make things right?